Cloud. Okay, so yeah, the topic of today's meeting is the Const eval skill tree. And so there's a link, I posted a link to the relevant issue, and thank you, Ecstatic Morris, for posting a link to the actual skill tree itself.
Put it in the Zilla chat as well.
Scott, you're something noisy, I think.
Oh, sorry about that.
Does anyone want to volunteer to take notes, or should we just construct those on the fly afterwards?
I'm on the phone. I'm not doing it.
Yeah, okay. Good way to opt out. All right. Well, I will attempt to take notes then, in the absence of anybody else.
I can try running the general topic.
Okay, that'd be great, since I think you have more familiarity with it than I do.
Cool.
Okay.
So, yeah. Today's meeting is basically to figure out the long-term plans of what is coming to Constable. I mean, we recently got things like if and loop, but we didn't have a big picture well written down. Lots of us had big pictures of what Constable should be doing in their heads, but it wasn't really shareable in a reasonable way. So we have created the Constable skill tree, which is the skill tree graph thing that Nico wrote, which allows you to generate a kind of dependency graph of features that depend on other features to first get implemented. And so you get like this in a computer game where you have a skill tree for getting certain skills. If you want like an end feature in Constable, for example, you want for loops with I don't know integer ranges. Then there's certain other features that you need to implement first before you can even think about going to for loops. For example, you need any kind of loop at all. So in the skill tree, you can easily see which ground features you need to be able to implement some higher level features that we all can kind of agree on we would like to see in Constable. Through this, if you open the skill tree, you'll see that on the very far left, there are some very prominent features, mostly because there's lots of arrows pointing at them. This means basically a lot of other features depend on these few root blocking features. Now we just have stabilized or are in the process of stabilizing if and loop. So these two can drop off. But there's a bunch of others that are also root blocking issues. The main ones being unsafety inside Constable, calling trait methods inside Constable. I think these are like the two main ones. There's others that offer certain nice features. For example, if we had a heap during Constable, but these seem a little bit further off. But the general idea of today's meeting is to figure out if the big plan that we are having here for Constable is something that's reasonable enough to lift a little bit of the work that is being done around language in Constable terms down to the Constable team and stop bugging the lang team for every tiny minor thing that we are thinking about. So originally, I think the plan was to discuss like the skill tree itself a little bit to explain like how we are reasoning a certain feature. But since Ecstatic Morris and Rob and I are pretty on par here, maybe the thing would be if
your
audio suddenly started getting really, really bad. It's like chopping out every other syllable.
Also the same thing from you at this moment.
Yes.
So up to which point did it work?
You could try disabling video.
Let's do that. Can I disable your video?
Yeah, there's in the desktop app. There's a button. I think somewhere I saw a button to not to receive video. Where was that? I can't find.
You
the
sound
button.
fine now, so if you want
Yeah,
to
you do sound fine now.
hand it
So
on to
just
somebody.
Yeah.
Okay, let's try this out video. So up to which point were you able to follow?
I heard my name at some point.
why don't you repeat what you were talking about exactly Morse doing? Yeah.
What do you want me to do?
Ralph, Ecstatic Morse, and I are basically on par with kind of the big picture that we see. There might be minor details that we're discussing about, but like it's more, we have a fairly good picture of what's coming. But the main question is like, how can we make sure that the rest of the Lang team is not just up to date right now, but if we we're discussing with the skill tree, but also keeping you in sync.
Yeah, and I think some of this also involves like design decisions that the entire Lang team should be involved in, certainly the unsafe stuff.
Yeah. So, I mean, I think we should try and resolve a bit about prioritization. Like what stuff do we want to be doing? Which of these items do we want to be doing in the near term? And then there's also kind of a separate question about how to schedule all this with the Lang team and like, how do we set up productive discussions? Because especially the unsafe unconst thing is pretty in the weeds and also sort of quite important to get right, in my opinion.
So I'm curious, right now, it sounds like most of the conversations are happening just between Ralph, Ecstatic Morse, and Ollie in terms of like determining big picture stuff, or do you also loop in, for example, Nico in all those conversations? Nico's a very highly contended for resource, so I wouldn't surprise you say no.
No.
Okay.
Not at all. We have some of these or most of these discussions in public, so technically anyone can be in there, but it's like sometimes people randomly participate, and this often brings up some good points that we need to figure out or clarify, but we don't have anybody like really looped in there.
Mm-hmm. Okay.
Yeah. Also, I think there's at least 3 places with like partial discussions about the unsafe stuff. So.
Okay. I suppose my most immediate reaction is, there is a question here in terms of whether we need a Lang team member actually looped in continuously to be a sort of representative of the Lang team and helping to decide, okay, now's the point where we should actually bubble this up to the whole Lang team, or if it's more that we should trust you all to make those kinds of choices. But like you said, it's not easy to like actually schedule something with the whole Lang team. But I can't tell whether your concern is whether it's deciding whether a matter needs to be bubbled up, or if it's more that you think which matters need to be bubbled up. It's just that it's very difficult to actually get attention from the Lang team right now.
It's kind of a mixture. So we're trying, for example, last year to figure out a bunch of features. And there ended up being an RFC, for example, that was like not had anything happen on it for like 9 months. And like, and in the end, the decision was not even to do anything on the RFC, but just do some experimental implementation, for example. And these are things that we could have probably figured out in just like the Constable group, and mainly just like bubbled up a smaller requests to the Lang team, like keeping it having the big picture like signed off by the Lang team, and then we get a little bit more, I don't know, freedom, I guess, to be more creative within that big picture. I don't know if that's a possibility.
So I don't know about anybody else, but my initial thought is that it is frankly much easier to deal with the little bite-sized chunks of like, here's a thing, here's the explanation of why it's safe, than it is to deal with, here's a giant RFC with 23 things in it. I think it makes a lot more sense to do exactly what you're saying of having a roadmap. And then the question is more just how much autonomy do we feel comfortable with for individual points? For that part, I would say, I don't think that we need to really be individually consulted at all on what's possible in nightly. And I think I would mostly be happy to say, here's like roadmap approval after some discussion. Feel free to move forward on each one of those individually and nightly, and then like check back with us before they go stable.
Mm-hmm.
That would be my first reaction. I don't know if anybody else, well, first of all, I don't know if that would address a large part of what you're asking. And second, I'm wondering if other people feel comfortable with that.
I think I'm sort of aligned with what you outlined there.
Totally agreed that nightly can be compiler's decision and we don't care that much.
I mean, this is kind of how we were acting before, but like there was always a lot of like uncertainty leading to long like cycle times between discussing it, for example, sometimes with Nico and so on. Yeah, I think basically if we figure out a scheme like that and everybody is feeling comfortable with that, we could push much more efficiently on implementing new features and like not stabilizing them, of course, but like figuring out if they are in a reasonable state and then having something to talk about during stabilization. Like, because sometimes we realize like, well, there's something doesn't work after the implementation, even though it seemed reasonable at the RFC point.
Right, that makes sense. But yeah, I think removing the uncertainty there of like giving a clear charter for please go ahead with this chart on nightly, ping us if something major changes, and otherwise we'll hear back with, you know, one or small batches of these ready for stabilization, pointing back to the chart saying, here's the plan, here's where we are in the plan, here's why this works now.
Mm.
That seems like it would be a great forward plan, and then we just need to go through your skill tree, which I think is a great presentation of this, and talk through kind of what are the major roadblocks, what makes different things difficult, what should we expect, that kind of thing.
Okay, that means I will need to extend the skill tree probably a bit to highlight these points more reasonably. Like right now, like lots of the subpoints just link to the issue, which makes it very hard to figure out like why is this even a blocker or like what's going on there. So representation wise, sorry.
I was just going to say, I think linking to an issue for more detailed discussion is completely reasonable, and it's more, it might be particularly helpful if all of those issues are, like some of them seem very, very clear up front. Like I was looking at heap allocation in constants, in the final value of constants, and that linked to const eval issue 20, which has a really detailed explanation in the very top comment it links to. And several of them seem to be that way. I think that if more of them look like that, then we'll be just fine.
Okay, that seems like a good action point for us.
And some of them are not linked at all, but I'm not sure whether that's like, this is a thing that doesn't have any complexity, or whether it's, this is a thing that we haven't written yet.
Mostly the latter. I don't think there's much there that doesn't have much complexity.
Okay. Like, I don't know, for example, just to pick a random example, I don't know once while let loops are available and the other dependencies are available, which also some of the lines are a little hard to follow where they're coming from.
Yeah.
But what is the other dependency of for loops? I can't actually tell.
Oh, it's calling trait methods inside Constable or Constable et al.
Where is that? I
Maybe
can't
one
find
of the
Feature gate const trait impl.
So the cool thing is that the graph will be more readable once we remove the things as they stabilize, because then lots of the arrows disappear.
Okay, but that makes more sense. So for example, once you have while let and you have the ability to call trait methods, then for just desugars to a while let sum equals something dot next and an into iter call.
Yep.
And is there any other complexity to for, like, I think there's an edge versus node question here. Is there complexity to for that makes it any more complicated than once you have its dependencies, for is trivial?
No, it's mostly that we might actually end up accidentally with features if all the dependencies of a feature are implemented.
Okay, that's exactly what I was wondering. Like, it's not always clear if something has innate complexity in the node on the graph versus if something is just automatic because we have its dependencies.
Yeah, so even in a for case, it's not that, because the iterators and need to const implement these trait methods. So you still need to do a change there. And this is true for most of the things. Like, even though it becomes trivial to do the change, you still need to do something.
Right. And that's in other cases, libs related items, like we can easily sign off on this roadmap from a Lang team perspective. There are points in this roadmap where you will need to mark a bunch of things const, which, you know, we're happy with, I think, beyond what we were just talking about, like check back with stabilization.
Yeah.
But then I don't know to what extent that's a libs question as well. And if it is, then that needs to, you know.
Yeah. We already have the nightly deal with the libs team. Basically, we can make everything unstably const fn, and the stabilization is then queried at the libs team.
Okay, so effectively the same deal we're talking about.
Yeah, but it's kind of happened very ad hoc. Like, it was basically a short discussion in a pull request, and then everybody was like, "Yeah, we don't want to see any more of these PRs. Don't ping us."
Stop pinging us.
They said it in a very, very much more friendly way than I just did. Sorry.
Sorry, what were people complaining about? What PRs?
No, so we had PRs where we added const to functions, but only in a way that users can't use it unstable. And that is basically, you still need a feature gauge to activate this this constness, even if the function itself is stable.
And people were complaining about you adding those consts?
No, people were complaining about, not complaining. Nobody was complaining. They were just mentioning that we don't need to ping them on these PRs. We can basically sign them off. As,
okay. I see. That was the complaint, was being pinged, not the PRs themselves. Okay, thank you.
Yeah.
Okay, makes sense.
Do we want to take some time to actually look at the concrete skill tree itself to make sure, because I think there was some concern amongst the working group that whether the Lang team is on board for everything that's on here, in terms of the big picture, or should we wait until Ollie revises it?
I would like to carve out at least some time for the unsafe discussion, because I think there we have a clear-ish problem statement and some things we could do, and this is a discussion that is definitely Lang team relevant.
Yeah.
I'd love to see that.
We should probably schedule an individual meeting just for constant safety, because this will definitely take up. Well, we can do it, but I think this is something that Nico has questions about, and it might get complicated if we leave him out. Like, we can definitely discuss it.
I'm barely involved with the rest of this, so
yeah. We can definitely discuss it here, but and then have a follow-up discussion with Nico if there's any leftover questions. So that's fine with me.
Would something like questions about where something fits in on the graph or whether it needs to be added to the graph be on topic here?
Definitely. But you can also leave that as a comment on the pull request if you just want something added.
Which pull request?
Oh, it's not. Can someone link the pull request for the skill tree, please? I won't be able to find it quickly.
Const eval skill.
I got it.
You got it? Okay.
Thanks.
I have a general question about the skill tree as a whole. Is this supposed to represent the minimum viable product, or Is this something where this is sort of what everyone pictured as like, well, here's like a bunch of stuff that would be cool to have, but in fact, a subset of it represents the MVP?
This is pretty much a wish list of things that we want and that people have opened issues about, or that we kind of wanted and maybe not even have issues about. It's not exhaustive, but most of the things here enable like things in user space or even in just the standard library that could be implemented. But if we add all of that here, we are basically adding half the standard library to the skill tree.
Yeah, and I think in terms of MVP, I mean, the const MVP is what we had like many years ago, right? Like it's just incrementally getting bigger.
Right. One thought on this: once the skill tree is like ratified and agreed to as a roadmap, then could we arrange to have an inside Rust blog post that talks about like, here's where const evaluation is going. Here is our, rough organization of like, let's say you want to do vec in a constant. Here's what needs to happen for that to happen. And some explanations of like, this is how we're building up from individual components. Just having a one-page blog post that explains here's where const eval is going will give a lot more visibility to here's cool things coming down the pipeline that you may be interested in.
That sounds like definitely something reasonable and cool to do, yeah.
I'd love to see this like with some formatting cleanup in terms of you can see where all the lines are coming from and going to. I would love to see this posted on the blog and get lots of attention for this is really fun stuff the const eval working group is doing.
Yeah, it's very hard to clean up graph with refs.
I mean, just delete, like, just focus on the most interesting nodes.
Actually, I had a suggestion there. I understand that it can be very hard to clean up graph viz graphs because you have no control over the layout, but I was wondering if you can at least annotate edges in some way with colors so that we'd be able to distinguish them visually when looking at them in the screen. Is that possible?
That might be reasonable. Yeah, yeah, I can do that. Basically, like the ground issues, like the things that get linked that have lots of arrows going to them, I can just color them along with the arrows going to them.
Right. Yeah. That's.
Oh, sorry. Go on.
No, you go ahead.
I was just going to say also, I've done a reasonable amount with GraphViz, and I've found that sometimes hand positioning like 2 or 3 nodes can pull that are particularly busy can sometimes get them pulled out from where all of the busy is, or just reordering them.
You're able to do that with the default layout engine on GraphViz? Maybe it's been too long. My experience was that the default layout engine ignores positioning if you
so it ignores like hard positioning. It's not it doesn't do things like I want this at this exact pixel position, but what it can do are things like, despite the fact that this is at depth 3 from what appears to be a root, I want you to position this at depth 5 so that it stretches it out a little bit more. You can do things like that, and you can also position things in ways that change the order of nodes as children of what looks like a tree. Anyway, I don't want to get into the micromanagement here. This is a conversation for Zulip of how to get it to look prettier.
We can definitely do that, but it's very, like, we're not actually using GraphViz here directly. We're using an intermediate tool for creating the skill tree. And these kind of features, I don't know. Like,
generating the colors.
And not worry about the bike shedding.
Right. Well, we can follow more about this in Zulip later. The point is there should be something we can do here to make this look nicer in a somewhat automated fashion.
Well, I want to be clear.
We'll clean it up.
Right. I want to be clear. I do not mind anything about like the overall visual appearance in terms of making it look prettier. The only concern I had is I can't follow where arrows are coming from.
Yep.
That's the only concern I have. I'd love to see that better. That's it.
Okay.
I wonder if there's a way to have a more interactive SVG where if you hover a node, it highlights all incoming
I was
edges or something.
literally thinking that. I think it's
That
possible.
would be beautiful. Yeah, if you can hover a node and see all of the inbound nodes highlighted in one color and the outbound in another, that'd be beautiful.
Magic web technology.
Anyway,
Okay.
go on.
Okay. So we still have the topic of constant safety that we could discuss today. Other than that, it's mainly we are cleaning up the skill tree, writing a blog post, and then you can, as a Lang team, basically sign off on the entire bundle as like the roadmap for Constable. Is that the bigger plan right now?
That seems reasonable. Felix, what do you think? Scott?
Yeah, that sounds okay. I was curious. So one of the topics that Ecstatic Morse had mentioned was prioritization. I don't know if you all wanted to try to just decide that on your own, or if you wanted feedback from us about like which items seem important. It's unfortunate the skill tree currently doesn't seem to other than the in degree of nodes. There's no like notion of what's important here, right? Like it reflected directly in the graph. But we could still talk about that hypothetically. I don't know whether you all. I personally don't have much instinct as to what is important besides my gut.
Yeah.
And
So
I have like very little notion of, there are one or two useful ordering constraints, I think.
Mm-hmm.
Like I agree with the thing that was posted in the last couple of weeks saying we should have proper loops as soon as possible so that people don't start emulating them via general recursion.
Yeah, so we mainly have, I think as a for prioritization, I think the important part is the high-level features, like which of these are priority that we want to get to users, and then look at the skill tree and figure out like, okay, then these low-level features are probably important too.
And by high-level features, you basically mean the nodes on the right-hand side, like is format more important than array equal, or is that
things like that? Yeah. Well, at this point, format is way out of scope. It basically requires all features.
Yeah, format is the worst.
Yeah, but
I would personally say that like at a high level, the two that jump out at me most are assert, because I would love to have static assert back. I would even take like a version of that doesn't support formatting yet and only supports static messages, if that gets us assert sooner, and then we could have panic with formatting.
Yep.
And then the other is the ability to have a static string or vec would be very nice.
Yeah, the latter is hard.
It is.
No.
But yeah, asserts would be lovely to have sooner, just because there's a lot of use case for them, and people currently emulate static assert using crates in the ecosystem that do things like create a slice with size -1 to create an error, or other fun things like that.
Yeah.
Yeah, we can definitely prioritize that one because the implementation for the non-formatting panic fully exists already. So you can already do assert on idly. This is essentially just we send it to you for stabilization and we're done.
And making the UX prettier, I think.
Yeah, what are the blockers for const panic without formatting? Is it just
there are no blockers?
Could be better.
No blockers.
From what I recall, there were some complaints that the way the error was rendered was not very great.
Oh yeah. Well, it wasn't even said that it wasn't great. It was mainly that people were wondering if it's confusing, but not even saying they found it themselves confusing.
I think this is the kind of thing where we need to make const evaluation more heavily promoted and explained, because when people realize how big a feature const evaluation is, and I mean that not just in terms of complexity of implementation, but in terms of what it will enable and how big a part of the language it will become, then realizing, oh, okay, we're just evaluating a big chunk of Rust code and that code panicked, and so we had a compile time error, then people will go from that's confusing to that's awesome. bonus if we add a couple of methods for like, here's how to give a more impressively formatted compile time error, like actually able to give spans and suggestions, but that's a different thing.
Yeah.
So real quick for prioritization, it seems like, so we could do const panic in a relatively quick timeline. And that would have some value. So maybe we should put that near the, if we're discussing a blog post of like if we're going to write a blog post, I think we should include like, hey, here's what's coming next, maybe in the near term and maybe in the long term. And const panic is a good sort of near term thing, along with maybe the mutable references, at least an initial implementation. Because the constraint methods is quite a bit bigger, and constant safety, those both have unresolved design questions.
Yeah, but I think constant safety is like the constraint thing also is big on terms of implementation, I think. Constant safety isn't. That's basically just, well, just documentation.
Yeah. And one thing is, if those are the two sort of big ones, I mean, I'm not all that helpful with the theoretical part, but like basically the trait methods are blocked on me. And then the constant safety stuff is not really blocked on me. So those can advance in parallel.
Well, one thought on this,
from one.
in the interest of trying to make sure we get you everything you need in the amount of time we have, why don't we allocate 10 or 15 minutes to having you go through the open questions around unsafe const fn so we can talk through what the plan is and we can agree that that makes sense. And then we could reserve the last 10 minutes or so of the call for, hey, here are things we'd love to see on the graph. Here are things we might want to prioritize differently on the graph, because that could be endless and we can take it to Zulip after.
Yep.
But
Yeah,
let's
that would be
take
good.
10 or 15 minutes and make sure we get you what you need on unsafe const fn.
Okay.
Also, Nico's here now, so.
Yep,
Oh.
hi Nico.
Hi, Nico.
Hello. So Ralph, do you want me to give a short intro, or do you want to start?
I can do that, I think.
Is there a shared document of any kind? If not, I might create one.
There's a HackMD.
Yeah.
The Zulip thread for this meeting has a link to the HackMD. I've been taking notes in.
I was just looking for the comment, the long one that I recently wrote, Ollie. It's in the union fields thing. There it is. One of the 15 issues.
So a very, very quick thing that I need to clarify in the very beginning. Any single unsafety feature that allows you to do something like transmute in any kind of way will give you basically all the other unsafe features that are flying around. So they are all interconnected, and we basically bundled it in the union issue because unions are the same thing.
Yeah. So the status quo is that union field accesses are allowed in consts, because that was even pre-Miri, that was already allowed, or very early after Miri. So we had to keep it, but they are not allowed in const functions. And the problem with all of this is that when you write unsafe code, of course, there are some extra requirements that you have to uphold. I'm not talking about general Rust code, because you have to make sure that you don't cause undefined behavior, of course. So the issue with const eval is that there's some new things that can go wrong besides undefined behavior, and it's doing things which are impossible at compile time. And the number one thing that is impossible at compile time is anything that depends on the concrete integer address of a pointer, because we don't have those, and we cannot have those because we have to be compatible with however LVM puts stuff, and like ultimately this is even non-deterministic with address space layer randomization and stuff. So if you ask in const eval if a pointer is greater than another, there's no answer we can give because we don't know in general. And that's a problem, because asking this question is possible in safe Rust. You can just take your references, convert them to raw pointers, and do the greater test, and it's all safe. So this is an operation which is normally doesn't even have any extra precondition, but when you do it in const, it's a big problem. And if you just do it, then you will just cause const errors.
So does this mean anything that takes a pointer and does as usize, or does this mean doing something with the resulting value that cares what its value is?
So the status quo is that if you cast to as, I don't know exactly what the static checks are ruling out, but I'm just saying in terms of if you actually get something to pass, like to run, if you cast something to usize, that works, but that doesn't actually do anything. So maybe I should say a bit about what happens under the hood. Under the hood, we have a symbolic representation of pointers, where a pointer is represented as a symbolic allocation ID, which is basically the base address of the allocation, and then an offset into that block. And so there's actually two kinds of values that a local variable can have in memory, which is integers or pointers. And when you do a cast, nothing happens. We just have a pointer value at integer type. When you cast back, nothing happens again. And that if you just cast forwards and backwards, that's no problem. But if you then take that integer, that seemingly that usize, and like divide it by 2, you enter a code path in memory which attempts to divide a pointer value by 2, and that will just error and tell you that you can't do that.
Oh, okay. So you are doing full like abstract evaluation on your pseudo pointer values, and then you just complain if you ever do something with one other than put it right back into a pointer.
Yes.
Okay. Does that also include making assumptions about the alignment of a pointer?
Yes.
Does that include things like offset of, for example?
Now I don't know where the question is going. So
let me not play 20 questions and to be very direct about it. I would be really interested in being able to subtract 2 pointers into the same object and get an offset within a structure in a constant.
Yes, we all want const mem offset. Right, so that's where I'm getting to. So we have these operations that are always safe at runtime, and at compile time in general not, but in special cases they are. So as Josh just mentioned, if the 2 pointers that we are subtracting are in different allocations at const eval, there's nothing we can do. Or if you're subtracting an integer from a pointer in general, also there's nothing we can do if it's the wrong way anyway. But if you have 2 pointers that point into the same allocation, they don't even have to both be in bounds. They just have to be derived both from the same base address. Then we know what the difference is because the base addresses don't matter. And then we could do this. And we even have an intrinsic for that already. There's the offset from intrinsic, which even the runtime form of that is currently still unstable, but I'm trying to push for stabilization. It's
yes, please. And for that matter, frankly, the fact that you could give a compile time error saying you tried to subtract 2 pointers and they weren't pointers into the same allocation, that's not a problem. That's awesome. The fact that you can detect that and say, you've done something naughty with pointers.
So the problem comes up when people write const functions, and that's why we make a difference between consts and const functions. When you just have a const, then it's just a thing that you evaluate, and either it evaluates correctly and we give you a result, and we even check if the result makes sense for the type, or evaluation goes wrong and you get a reasonable error. But when you write a const function, then that internally uses unsafe, then just like when you write a normal function that is externally safe but internally uses unsafe, you should make sure that it works well for all reasonable inputs. And the rules for that are different for const and runtime. And there's no way we can test that and give you errors. So if you write a const fun that takes a reference, and then what it does is, and that's all safe code, is it casts it to an integer and multiplies it by 2 and returns the integer, then that you don't get an error in your code, but there can be users that call your const fun that don't do anything weird. They just call your safe const fun and they get a weird const eval error. And that's not great. And that's basically
that seems like it raises a whole family of questions. Is there a way of doing const tests? Can you declare a test that runs on a const fn and the test runs in const mode such that if it would be an error to evaluate the const fn, you'd get an error?
I think if you just have I don't know. I don't know much about enough about testing stuff. If you just have a constant in a like CFG test module, wouldn't it do that?
Yeah, that works.
Yeah, but the issue is testing all possible inputs to the function. Which is
Yeah, well, but I mean, you just have a constant of type unit, and then in that constant, you have your test function.
Or you even have a test and use, if we make const blocks of things, then you can write a test inside a const block.
Yeah.
That sounds promising.
So I might be misunderstanding the problem that Ralph is outlining, but this surely isn't the only case where we've got a const eval error that only surfaces at effectively evaluation time of the body of the const fn, right? There must be other instances like this. No?
Basically, we consider this okay for panics and overflows because we do the same at runtime. But with const, there's a whole new class of possible issues here. And so this is part 1 of 2 of the possible problems here. This is a teaching problem mostly.
I think one thing that Felix is also pointing at is that if you do undefined behavior, like indexing an array out of bounds or
that's the second
something.
point I was going to get to.
Okay, cool. Continue.
Right. So the other possible problem is that your const code could actually cause undefined behavior.
Wait, Ralph, before you continue, I think I know what you mean, but I would find it helpful to write a very concrete example of a const fn. Can we do that?
I mean, the one that are just for the first kind of problem.
Maybe we can put it in the notes or something.
Yeah, I mean, I spelled out one when speaking, but you're right, that's not very useful. So here's a fairly trivially nasty one.
Okay, oh, I see. You put it in Zulip.
Huh? I'm putting it in the yes, in the chat for this design meeting.
Got it.
So that's a function which basically, in the terminology of my blog post, is not const safe because there are reasonable inputs for which it doesn't behave reasonably at const time. So that's a function that we don't want people to write, basically, just like we don't want people to write safe functions that cause undefined behavior.
Is there an input where this does behave reasonable? Like if you took a number and cast it to a reference and then called this function, it would work? Is that the idea?
Well, that would be UB technically because it's dangling. If you make I32 a ZST, you could imagine something like that, or if you just have more complicated functions.
If you make what?
If you replace I32 by a 0 size type, so that an integer can actually be a valid reference.
Okay. I mean, because the idea here is that, because this seems like it's just always wrong, but the idea is that
Yeah, that's because it's an artificial example.
Right. There are cases where, depending on the specific values you provide, it might or might not.
Right. And so basically we have these operations that we call unconst, which are things that are safe at runtime but bad at compile time. And there is some discussion around whether, like, should we help people make sure that they don't have that? Should we require an unsafe block in this function to acknowledge that that's currently what we do, I think. For some of these casts, they are unsafe in const functions. Should it be a different kind of keyword because it's a different kind of property? That's some of the questions that are in this space. And then just to complete the problem statement, the undefined behavior thing, of course, you can cause undefined behavior at const time, just like in normal code. Once we allow unsafe, you can just do an out of bounds access, or with your raw pointers, you can do all sorts of nasty things. And we detect most, but not all of them, because, for example, for performance reasons, we don't check that every Boolean you ever create is actually true or false. And so there is a question here of what do we guarantee or not about const code that causes undefined behavior. And there is a spectrum here where we could guarantee that it is caught, like full Miri style, all the way to it causes undefined behavior on the host compiler, which could actually happen if, for example, we jittered const code and then ran it without a sandboxing. And like somewhere in there is a point that we have to decide is where our guarantees are for const eval.
So I got a little lost on the second half. I mean, I understand the concept, but I have a few questions about the first half, though, still, before we go that far. Just to make sure I'm clear on it. So, in particular, what would you say about a function? Like, what if the eval function just cast x to a usize and returned it? That's a case where it doesn't directly cause any problems, but the consumer might.
Yeah, that's also an eval
right?
function, because to use some of the formal terminology from that blog post, a runtime correct function is one which takes safe values and returns safe values.
Yeah.
A const correct function is one that takes const safe values and returns const safe values.
Right.
And a pointer value in integer disguise is not a const safe value, because there are operations that we want to consider const safe, like multiplication by 2, on which that value errors.
Right. So it'd be analogous to returning a dangling pointer and calling it a safe reference.
Exactly.
Yeah. In the case of actual UB that you were bringing up in the second half, in theory, if we had the dream of a MIRI that detects all UB, we sort of would always, I guess, we would always detect it, and I guess that's why you brought up the JIT code, because the idea would be maybe we wouldn't detect it if we...
Well, I mean, already right now, we are, I think, correct me if I'm wrong, Ollie, we are running MIR optimizations before doing CTFE.
Yeah.
So code that has UB will already show weird behavior and not be detected as UB if these optimizations exploit the UB.
I see.
But the behavior is currently constrained by the fact that we are running it in an interpreter. So the worst thing that will happen is it will return an unexpected value, and the return value of const eval is in general not one value, but like a graph of allocations that get added to the global allocation map.
Yes, okay.
They have unexpected context, but that's the worst thing that can happen. It will not mutate your existing const, like other const maps that you already created. It will not, and it will not cause UB in your host compiler.
I didn't appreciate that we are running after optimization. Okay, interesting.
Is there any way it can produce something that becomes UB at runtime?
Yep.
In principle, yes. We are guarding against that as good as we can by validating the return value of a const. Like when you have a const that says it's a Boolean, we will check if the final value is true or false. We don't check this for intermediate Booleans, but we check it for the final Boolean. But that check doesn't cover all the possible cases. So there's things...
Especially it doesn't cover user invariance. So if the user has some wrapper around a raw pointer that they have some expectations on that raw pointer that they'll be able to dereference it at any point, that will definitely blow up.
Like you could just create a const vec that has bad stuff in it, and then in safe code it will blow up. So this is definitely, yes. There are more long-term consequences, so to speak, of bad const eval results. Even if you say it's just an arbitrary unspecified const eval result, if you have const eval UB, that could still mean UB at runtime, depending on how that const eval result gets used.
Especially with user invariance, it's a good point.
Yeah, and there's no way, there's nothing we can do against that. That's just a fact of life.
Right.
If you just transmute a random bundle of integers to a vec of, I don't know, vec string or something, the checks will never be able to catch that.
Well, we will check the non-null thing, but that's it.
All right, true.
So
that says to me that basically that one end of we guarantee that we're going to catch all UB is impractical at best.
Yeah, I mean, I agree. It's also impractical for performance reasons. Like, I don't think we want to do full MIRI style validation and stack Bowers checks during CTFE. That would seriously regress our CTFE performance.
Yeah. Okay.
That might be a mode we all...
Yes, I was just thinking opt-in to ask for it might be nice.
That's not easy because currently MIRI is a different instance of our...
What we can do is make MIRI, which compiles everything in MIRI mode, also recompile all constants with MIRI instead of with the const evaluator.
Yes,
I
guess.
Can we not go too far down this?
All possible cases of your violate user invariance, and that will cause UB.
So I have a pretty hard stop at the end of the hour.
Yeah.
I would request that we not go too far down this road of like how we can make MIRI catch those kinds of bugs. But did you actually get to? I mean, I feel like you showed the two problems.
Yes.
But you didn't talk about the potential solution.
Okay, well, I talked about the potential, so the design space for the second problem, which is a guarantee anywhere between it's detected to no guarantees at all. That's not very helpful, I know, but like I'm not sure what to say beyond that. For the first point, I think the options we discussed so far are: number one, make these unconst operations unsafe. So that's currently what you have to do. You have to write this eval function would not be accepted. You have to add an unsafe block. And then you have to be aware, hopefully there's documentation or something, that this unsafe block inside const actually means there's more stuff you should take care of than you would otherwise. because of these unconst issues that we talked about. Number two, we ignore it. It's not actually going to cause UB. It's just going to cause a clean interpreter shutdown. It's not going to have all these side effects for optimizations and stuff as the normal mirror UB. So we could just make it a safe operation and try to otherwise teach people about it. And number three, have a different keyword, unconst, with a different kind of blocks to acknowledge the separate level of guarantees. I think that's the three options that I saw.
Okay, I just posted an example also of like, just to more elaborate the theme of how you presumably sometimes want to do wrapping. I guess in my example, the unconst would basically, those two unsafe blocks, well, I guess all the uses of the word unsafe here would change to unconst.
Yeah, that's the really good question that Ollie raises every time I bring up unconst, is like, is there even any unsafe left then, or is just everything unconst? And I'm not sure I have a good answer.
It would be like an unconst FN, I guess, also. Or what?
Maybe.
It's a little surprising. It's not a normal FN. It's not a const FN. It's an unconst FN.
It's actually an unconst FN or something. I don't know.
The bad part.
I guess unconst FN is sort of, it's both.
I'm worried I misunderstood Ralph's second solution about just ignoring it, because I thought Ralph had said earlier that when you say it won't cause UB, it'll just a clean interpreter shutdown. First of all, I thought you said there was an example where it can cause UB at runtime earlier in response.
No, that was when
Scott.
There's two ways in which, well, there's more than, but there's two interesting ways in which const eval can go wrong. It can, there can be UB during const eval, like out of bounds access of your get unchecked access, or like using an intrinsic the wrong way, like reaching the unreachable intrinsic. And there can be, you did a thing which is well-defined runtime semantics, but not now, like anything depending on pointer-based addresses. As long as we don't have optimizations, which I don't think we will get, I hope, that rely on the latter not happening, those are very distinct errors, because we can have optimizations that rely on unreachable code being unreachable, and then really weird stuff can happen, even during const eval, because like the unreachable branch just gets removed. And so there's no way to detect the UB anymore, because the unreachable marker that marked it as UB isn't even there anymore, and everything just gets weird. I can come up with concrete examples later, but not on the top of my head. Whereas if it's just the arithmetic, then there's no optimizations that are going to assume that your pointers are not weird pointers. So we would just get to the arithmetic with the multiplying your pointer value by 2, and we see, oh, we can't do that, and we will clean.
Okay, well, hold on. Let me stop you, because I'm worried that you're explaining a lot of details that I don't necessarily need. I want to know the bigger picture of like your claim here. I think is that everything that you can't detect would be caught by some sort of sandboxing, you know, in the worst case scenarios. And in any case, whatever catching. Well, okay, hold on. Well, if I'm wrong about that, correct me. But let me just finish this for a second. The worst case behavior you're expecting, given whatever safeguards you're planning putting in place, is some kind of error or compile time, like it just says something went wrong, sorry. And it may not be a great diagnostic, but it won't be undeterministic behavior from your resulting object code, because there will not be object code. There will not be any object code.
One. That is true. That is true for the unconst problem.
Okay.
That is not true for the UB during const eval problem.
Yeah.
Okay. Okay. Right. I forgot to outline that there's actually two problems, even though you said that a couple times. Okay. All right. So maybe I need to understand. Okay, I understand that the three solutions you've outlined are only about the unconst problem. You haven't talked about solutions for the UB problem yet.
Well, there I said there's I mean there's no. This is less of a solution. This is more of a, we have to decide, like, what are we going to guarantee? And
right. And before we decide that, I want to understand what would even be possible to guarantee.
That's okay, fair.
So for the UB problem, what is the solution space there?
I think the strongest guarantee, given the user invariant thing that we can give, is not very strong, which is that when you do UB during, well, no, we could do stronger. So the strongest UB that we could give is that we will detect UB during const eval, like we have a full MIRI running during const eval, and we will just abort execution when it happens.
which would not only make Constable much slower, but would also require to use a lot of memory, because every const fn would have to exist in optimized version and an unoptimized version.
Yes. That's the strongest possible thing. That's probably unrealistic. But so given that that's unrealistic, all realistic solutions are probably going to involve that when you have UB during your const eval, the return value of const eval, like the final value in the const, is unconstrained. Like it could be anything. It's unspecified behavior, basically. So like you have a thing that computes a bool, and the computation of that bool checks like that has UB. Well, result is unfortunately that your bool might be true or false, or it's some other value. Could even be uninitialized memory. Now that specific case for bool, we can and will catch. But if it's not bool, if it's vec of I32, then what this means is you have a vec of I32 that's a completely arbitrary bag of bytes. And if you then use that at runtime, of course, arbitrary bad things can happen.
So I'm still trying to, so the answer basically is it's either detect UB via a method that's too costly to really consider, or give up and accept that some kinds of coding patterns.
You can give up even more. Like we still guarantee that compilation won't go wrong in arbitrary ways. Like the Rust compiler will behave cleanly around UB CTF code and will either show an error or produce an arbitrary constant, but it won't itself do arbitrary other things.
And it will even still be deterministic.
It will even still be deterministic and does not violate like generic types, const generic soundness. Yes. That is something we can and I think should guarantee. But yes, once you then actually run the resulting binary, there is realistically not much we can do about constraining that.
And that part at least seems totally reasonable to me, that whether it's at compile time or not compile time, if you run unsafe and it's bad, then bad things happen.
Yeah, and maybe we would detect
at runtime
latter kinds of things. Like, so we have the same game as with normal unsafe Rust code. Like it can cause arbitrary UB, but we are trying to give you tools to work, like figure it out. And then there is an even more extreme version where we don't even guarantee that, because we could imagine that like we could implement the unchecked array access during CTFE with a truly unchecked access in the compiler for extra performance or something. Like I'm not saying that's reasonable, but it's something we could do. We could JIT the CTFE code and just run the assembly without any checks. And then we would escalate even one level further. I would say we have actually compiler UB from CTFE UB. I don't think we want that, but by making the other guarantee that I mentioned earlier, we are excluding those implementations.
I certainly don't want that. But I think we're at 11:02, so at least
Yes.
Nico's got to go.
But I think we at least laid out the design space and the questions, I hope. That makes more sense now.
Yeah, feel free to review my the hackmd at your leisure to figure out if I got it right, but okay. Okay. Yeah, we were over time now. I think Nico had to drop off. Ralph, did we cover everything you wanted to about unsafe stuff? We certainly spent a good amount of time on it, but.
Yes.
Okay, so I think Nico was actually present then for everything you wanted to talk about, and,
Yep.
and it got across to them. Okay, good, good. All right, I think the only, I know it's over the hour. Is there anything we need to decide besides, I think we've all sort of collectively said we'd like to see more of the skill tree, like sort of cleaned up and maybe written about in a blog post, and then we can have a final sign off of the big picture. Does that sound right in terms of what the action items are?
Yep, that's what I got.
Okay, great. Anyone else want to say anything, or should we just call us to the end? This is the end, right?
Yep.
Yeah, I mean, I guess at some point we will probably have to have another meeting then about this unsafe stuff. I'm not sure what is necessary to be done before that. Is there more? Do we need to work out more examples or something?
That's
or
actually a good point.
More time.
It's that was a great. Here's sort of some bounds on either side of the space. It felt like we were getting towards a. You think that this sort of particular point in here is probably the restrictions that we want to give. That seemed plausible to me, at least. I don't know if that should become like a write-up that gets signed off as, yes, these are going to be the unsafe guarantees, or?
I'm in the process of writing a Rastonomicon chapter for Const, not because it's UB, but because it's unconst. And I've got to rewrite the entire thing. I have a PR open, but don't read that for now. But basically, that could be the sign off of, like, if everybody feels like there's enough information in there to handle unsafe in constfn, then after that we can do an FCP on actually stabilizing some unsafe things.
Does this require an RFC?
It's not an RFC.
No, but does it require an RFC? It seems
Oh,
like
that's a good question.
Large-ish decision.
I don't know.
It sort of feels like it, but
I don't even know what to write an RFC for that.
so actually, one thing we talked about, like unconst, is unconst unsafe, all that sort of thing. How much of that, so I guess we didn't make a decision on, do we want to say that unconst stuff is actually unsafe, or if it just dies at evaluation time?
So
I don't know that I have a strong reason to say, oh, we should definitely do it needs to, like, comparisons need to be in an unsafe block versus have an unconst versus just say that it'll be a evaluation time error versus, I don't know.
So any kind of unsafe feature that allows you to emulate transmute will allow you to do unconst things, because you can basically just transmute a reference to a U size and then compare these U sizes, which is a safe comparison in any scheme. So if you can break the constness guarantees with the regular undefined behavior things.
Yeah, but that's expected.
Yeah, so the unsafe stuff being unsafe, yes. It was the unconst stuff from safe code that I didn't feel like we got this is definitely the way that we want to have this work.
I agree. That's still wide open. I mean, there's like, we could just declare these operations UB at const time, and then all the other, like, and then see there for what we do for UB at const time, or we could give, and then it would have to be unsafe blocks and stuff, or we could give stronger guarantees.
We can also just punt on this decision by keeping it unstable for as long as we want, because we can stabilize the other things without even considering what to do about them.
Stabilize transmute in consts outside constfn, and then some people say, but we shouldn't do that without the constfn thing. And
no, I mean, stabilizing transmute in constfn can be done without stabilizing raw pointer to comparisons or raw pointer to integer casts.
Oh yeah, right. I got the dependency the wrong way around.
Yeah, so we can stabilize all the regular undefined behavior stuff without stabilizing the const
as casts.
But we have to answer the question of what happens when you
exactly. We still have to answer the same question.
But we can just say it's UB, and then we can always later refine that, because UB is something we can refine later.
True. So I guess one answer I would have for what should be an RFC, it sounds like what is the behavior of unconst values is a place that would make sense to me, at least, as an RFC, because you've talked about at least about 3 different possibilities, I think, today, maybe more. And if you were to say, I think we should do this one, here's the other 2, here's why those other 2 are less good than the one that I think we should do, I think that would be a very nice RFC for people to be able to read.
It sounds like we also have another RFC, which is what is the behavior of UB during const eval, and it might actually be worth having that first. I think there we have a more agreement on what the solution is, and and there's kind of a dependency of the unconst thing could just say it's UB, and then we have to have that other decision made to even know what that means.
But can we answer that question without having answered the unconst question?
Yes, we can just say what UB during const eval means without saying what exactly triggers UB during const eval.
Right.
When you say saying what UB during Constable means, you mean like putting bounds on how bad it can be? Like, for example, saying it can't cause UB within the compiler itself? That's what you mean by that, right? Just it's not like actually tying down concrete semantics. That doesn't really make sense to me for UB. It's more of a co-inductive kind of thing.
I'm not sure if it's co-inductive, but like UB is one of the possible failure modes of CTFE, and this wouldn't specify when we enter that failure mode. It would specify what happens if the failure mode is entered.
I see. I was more thinking saying what can't happen, like saying, well, we don't know what happens exactly, but we can tell you some things that can't possibly happen.
I mean, what happens is what happens might be just one of those things.
I am worried that we are way over now, and I don't want to hold everybody else in. So thank you very much for your time, everyone. And it sounds like people know what they need to do next. Okay? Great. Thank you.
Excellent.
Bye.
Thank you, Felix.
Thank you.
Yeah.
Thanks, Ralph.